Welcome everyone. Hopefully I'm coming through and everybody can hear me. My name is Frank Simmerjay. I am the chapter president and I want to welcome you to our meeting. I'm going to wait a few minutes, let folks trickle in. And I will be doing a quick intro and introduce our presenter tonight in just a few minutes. So give everyone a chance to come in. Consider this the 5-minute social time prior to the meeting.
I wanted to do a quick test. Is there much of a delay in the video or audio?
Seems to be okay from my side, Abraham.
Great. Okay. Thank you. So do you do anything to kick off the social activities or ask a question or?
We have wild parties, Abe.
Usually involves lots of drinking and
Awesome. Yes, I gotta go to an in person meeting next time.
And you know, I'd like to be able to say that there is a slide that I had to hide in our deck that talks about next month's meeting. I'll speak to it regarding next month's meeting, which is intended to be a FaceTime. So,
ooh, very nice.
So let's give it.
So you're gonna play with all these guitars in the background, Frank? Come on, you've only got 4 or 5 of them hanging there.
Just a few. You know, let's see. My Fender,
Ooh.
my Jackson, Cordoba.
Nice.
My only Fender is attached to my car.
You know, just putting things in perspective and you know, just having a little bit of casual fun about that. It's funny because I've been studying, picking up guitar for a while, but interestingly enough, COVID encouraged me to actually practice. So I've been practicing now for almost a solid year on a daily basis, which is something very unusual because it actually is, you know, it's like, what else do you do at night? And you know, as kind of a fun intro is my latest and greatest that I've added to my lineup is House of the Rising Sun by The Animals. So I have a feeling some of you probably appreciate that song.
Mm-hmm. Nice.
Encore.
My wife keeps trying to convince me that I should sing, which is, that's a mistake, but.
You should let us be the judge. You should, if you can.
All right, well, just give folks 2 more minutes. I see people are kind of trickling in at a good pace. This is unfortunately the one drawback of these team meetings, and possibly cross my fingers, maybe the last time where we only have a Teams meeting and not have the physical face-to-face, because I believe that in these engagements are usually much more effective when we have the opportunity to actually interact. Let's hope the world allows us to do that.
Well, I tried my best to actually make these interactions and talks interactive. So I hope everyone can help me out here to get through this material. And
so what I would say, Abraham, I very highly likely think that there's going to be a good portion of people that are going to be eating while they're sitting listening. So they won't be asking questions. That's my guess. That's exactly what I would do too.
Okay.
You know, cheers. It's like I'm already on number 2 right now. So.
Well, if you've seen any of my talks, you'll see that I do get the crowd involved. So that's a challenge for me.
No, you're just a rabble rouser, Abe. I've known Abe for many, many years. And I've attended several of his talks.
Yeah, Gene, you were featured in one for a little while.
Uh-oh,
At RSA, yes.
yes, yes. Well, now that everybody's running off to Black Hat and DEF CON, we'll see who's left.
All right, well, we hit 20. I think that's a pretty decent number for an event at 6:30 when it's on Teams, in my opinion. I have a feeling recording will probably be viewed by a good portion of the membership, as long as you give your consent after this event. Let me jump through, just verify my slide is up, right, Abraham? You can see it?
I can see it.
Okay, good. So welcome everybody to the August ISC2 Seattle chapter event, general meeting. We've been conducting these team meetings now for a better part of the inception of this chapter, which is a real shame, but at the same time, we were able to get this chapter off the ground without ever meeting anybody. I mean, which is a little bit strange, but anyway, the leadership team that has been supporting this effort has to be commended, including Gene, who is the vice president, joining us tonight, Joe, who is director of membership, Lori, I'm not too sure if she was able to make it tonight, but I will say, oh no, she is. So Lori, our most recent addition to our board as our treasurer, Jake, who I believe cannot join us because he's on vacation, is our director of communications. Stephen, who is fighting fires right now, and not virtual fires, but real fires. I guess there's something interesting going on in Wenatchee, and he's trying to help some people out. So hopefully he'll join us if he can. I know he's trying to help some folks out. And Mark, our secretary, who also, I believe, is fighting fires, I think in the virtual sense. I believe he's dealing with some folks in Asia that requires his attention, so he's on a late meeting. Thank you all board for supporting the chapter. So I also want to thank the initial sponsors of the chapter. Up until now, we've been keeping the sponsorship simple and relatively low cost. And certainly Caliber stepped up to be a featured sponsor. IOActive and Cybereason have since stepped in also to support us at a sponsorship level. And I expect that there's going to be a couple more names that we'll be adding here shortly, which I'm really pleased to hear. So if you represent an organization that you feel that should be represented here, the current sponsorship is $500. I mean, it's dirt cheap. Good luck in finding another association where you, as a business, can support and also help the community. As everybody's aware, the chapter's mission is to help the local community when it comes to information security and cybersecurity. I would like to think that we have been able to do more than we have. The reality is the circumstances of the year have not made things easy, but I believe that our organization is definitely here to be able to foster the right level of communication and impact in the community when it comes to cyber awareness and cyber certification. There is no question in my mind, and I think in many people's mind, that that ISC2 right now with its CISSP and its other certifications reflect the norm of what cybersecurity accreditation represents. With that said, we like to pull in some great speakers during this past year, and moving forward, we're going to be continuing to pull in some great speakers. So tonight we are honored to have Abraham Kang present on something that actually I am deeply interested in, because I have to deal with this on a regular basis. Everything associated with Graph and GraphQL and GraphQL is now the new norm. I know, being a Microsoft employee, we talk Graph all the time. So this is the new space. Now, to know about it's got some vulnerabilities is not really a surprise. Being in security for as long as I've been, I'm sure there's something to explore. So with that said, I'm not going to intro you anymore, Abraham, except to say that you have one hell of a bio, and we kind of cover that. while I hand over, I think I've already made you co-presenter, so you should be able to take control of screen share. So I'll let you go ahead and start that process.
All right.
Take
So
take over the presentation.
you got it. I'm pressing the button.
While you do that, and I'll stop sharing. One of the things that I wanted to make sure is that folks stick around at the end. There's a couple of announcements that I want to make that I'm saving to the end. I would like to hope that we have opportunity coming up in December, and we have another opportunity next month. I'll speak to even if I don't present. So with that said, now that Abraham is starting to do his screen share, I can hand it off to him, maybe.
All right. Can you see my slides? I'm about to put them in presentation mode. I hope it doesn't.
Yes, we see them.
I see the slides, but right now yeah, there we go. Now you're in presentation mode.
All right. Great.
All right, all yours.
Thank you. So when we look at GraphQL today, as Frank mentioned, it is getting very popular and it is used in many locations. And we got to ask ourselves why, because we got to understand what the perceived advantages are and how it's being used. If you look at today's environment, we have a situation where microservices has started to predominate in many architectures. And when you have many different microservices, you don't want to necessarily call each one individually for the data you need. So when you stick a GraphQL server in front of these microservices, you provide a single interface into these microservices that kind of unify the experience of getting the data and modifying the data that the enterprise deals with. When developers talk about REST, they say, oh, the reason why I like GraphQL is because REST gives me too much data, or it's too coarse-grained, or it doesn't provide me enough flexibility. Now, what do you think is wrong with this? Does anyone have any ideas? And just for a hint, I try to help you out with the part that's in red, typically on the slides, to help interactivity. But if you look at this is what is used to tell the GraphQL server what data you want. Can anyone think of something that's parallel, where you're asking a data for data? What language would be a parallel to this in the relational world, for example? Anybody know? It's a 3-letter acronym.
SQL.
Yes, SQL. So this is kind of like a SQL. I mean, it's not syntactically like SQL. But if you can imagine a URL endpoint where you can give it a query and tell it what data you want, and it returns that data to you. Now, is anyone kind of concerned about that? What if I told you that basically, we've already said this, you could submit any validly formed query to this endpoint and get the response? How about if I told you that basically through this interface, you can do inserts, updates, deletes, fetches of data? Does anyone think that this is, how does this compare to what we currently have with our current architecture, which is basically you make a request to an endpoint and you give it parameters, and if it's written well, it's going to use a prepared statement to bind those parameters into a SQL statement. It goes and fetches the data, and it returns the data back to us in a JSON format So how is this different? Can anyone tell me, is this better or is this worse from a security standpoint?
All right, well, since no one's speaking up, I mean, obviously, there are some serious risks when it comes to security, but it is practical.
It is very practical. I mean, it helps you out. As a developer, you love it. But the thing is, before, when I was trying to do SQL injection to modify the query, like if I called an endpoint and I wanted to get it to return data that it wasn't expecting, but was in the database, I had to use SQL injection and, modify the query with a union or adding additional columns. And here, do I need to do that? I mean, if this is the URL, do I need to do any special, trying to figure out, if I need a single quote here, or if I need a double quote, or if I need to, put spaces.
I think that, I don't know if this is where you're reaching for, but I know that there's a lot of helpers along this. That's the biggest difference, is there's helpers that will basically correct it won't just return an error, but there's helpers that will resolve your error in your query.
Right. Yes. So if I told you that basically this request was made by a browser now, this is not a request from your application server to your MongoDB or whatever. This is from the browser to the server. Then how do you feel? Or what if I told you that the GraphQL server receiving the request authenticates the user via session cookies? Yeah, that's true. I'd like that. I just saw the comments. It looks like a breach waiting to happen. Yes. So here, if you think about it, this is essentially a SQL type interface to the database from a browser client. And remember, you can do inserts, updates, deletes, in addition to queries. So if the server is authenticating the user via a cookie, does anyone know what vulnerability out of the OWASP top 10 you now have? If they aren't using a CRSF value. Does anyone know? Hold on just a second.
You're not doing authorization.
Yes, that's true. You also have cross-site request forgery, right? Because if the session cookie is passed, when you click on the link, if that's a mutation, which is something that updates data, then the victim who clicks on the link now has updated the database with their session cookie and their credentials, and you trick them into doing that. Now, let's talk a little bit about GraphQL so that everybody's on the same page and understanding what it looks like. So on the left, what you have is what a typical query looks like. When we say person ID equals 5, does anyone know what vulnerability that's typically in the OWASP top 10 is associated with this? If what's being returned is the person object that has the ID of 5 with all their information. So does anyone know what vulnerability is here? It's a 4-letter acronym. Yes, somebody got it. IDOR. Please speak up. IDOR, yes. Insecure direct object reference. All right, so here, if you look at GraphQL, there are basically, yes, I'm sorry. There are 4 different categories of things that you can do in GraphQL. Okay, we have types, which describe our objects that can be returned. We have queries, which are essentially select statements. And then we have something called mutations, which basically are inserts, updates, and deletes. And we're not going to cover the subscriptions, which is basically a subscriber model that's supported by GraphQL. This is what a very simple schema looks like. So these types here are your object types, and you have your attributes, and each of these attributes can be a simple type or can be a complex type, which is another object. And those can be navigated via a hierarchical type mapping, where you go via the, you'd say lift, and then open square or open curly bracket trail axis, open curly bracket, and in the trail axis, the trail object, you could get any of these fields, right? And here's another complex object type. So these are all the types that can be used in queries, and here are your mutations. So, no worries. So here, when we look at this thing, can anyone tell me what an enterprise schema, how it would be different from this? Would it, you know, what's the major guess? If this is like a toy model, what would an enterprise GraphQL schema that's dealing with a lot of different, you know, systems and components, what do you think is going to be the major difference?
I'd say it'd be a lot more complicated than what this is.
Exactly, exactly. So you're going to have a lot more of these types. You're going to have a lot more of these queries. And notice that when you have these queries, when a type is specified as a query, the type itself and all of its sub-nested types all the way down are going to be exposed. So you might think here, just conceptually, when you look at this, oh, I'm just exposing this lift object. But in a real enterprise schema, you're going to have a whole bunch of these types. They're going to be chained together n levels deep. They're going to have, you know, recursive and bidirectional relationships. So you don't know what type actually is being exposed when you do this, because there's so many different complex paths that you can start from this root node and traverse to get to. And that's where a lot of these things have problems, is because basically you have these complicated models and you think you're exposing one thing, but when you chain it down, you're exposing a lot more stuff. Now, take it out. That's the, oh, yeah. Okay, whoops. Okay, yeah. So let's look at another example of a query. So notice here, you can have a generic query. When you give the server the query, you're going to say query, that's a keyword. And then you're going to say all lifts, which is associated with here, this all lifts query. And then inside that, this takes a lift status, and it's optional because it doesn't have the exclamation point. So here we have all lifts without it, and here we have all lifts with it. And the status is basically a type that can be open. There's an enum that defines it. And here we're getting all lifts, and for each lift, we're getting the ID, the name, and the status. Here, we're now not getting all lifts. What lifts are we getting? Does anyone know? The lifts that are, and this is like ski lifts. So ski lifts are typically in two states, right? They're on a, has anyone been to a ski resort? Is my volume not loud enough, or?
No, we can all hear you. You're just stumping us. That's all.
Oh, okay. I'm sorry. So in a ski lift, the lifts are the things that carry up the mountain, and sometimes they break down. Most of the time they'll be open. And so here, with this second example, we're getting all the ski lifts that are basically open. And if you want to try this out, this URL here at the bottom right, you can click on it and you can try to type this query in and you can see the results. So here is an example of the output of this query. So as you see here, and I apologize for putting this here, you can see all the lists where they're open. The other thing you have is a mutation. And this mutation is where you can basically do your insert, update, or delete and execute some logic. So here we're basically setting the status of a lift, a ski lift, where we specify the ID of the lift and the status that we want to change the lift to. So it's pretty nice, right? I mean, it's pretty flexible. The thing you got to understand is that these queries can't magically just go get the data, right? They've got to be translated into some type of logic that knows where to look for the data, how to pull it back, how to make the update, how to make the changes. And so those things are controlled by something called a resolver. And a resolver is just basically a mapping between your type and the actual logic that's going to go get the data for that type. And here we're using some API to access the data by the ID that's passed to it and populate these human objects that are going to be returned. The problem is, because we're dealing with code, then basically what can live here? And what is it of interest to us as AppSec professionals?
Injection.
Yes, exactly. All the injection vulnerabilities, all the different kind of file path manipulation, SQL injection, all that will be here in the resolvers.
Is it type safe?
Is it type safe? So it depends on if you're using TypeScript and what language you're using. So most of the time, most people use JavaScript for the GraphQL resolver logic. So it kind of depends on that.
I'm pitching you a softball.
So in most cases, since you're using JavaScript, no. But the thing is that you're using TypeScript, you can get some type safety out of it. And but the key thing here is when you're trying to look for vulnerabilities, application security vulnerabilities in a GraphQL application, this is one of the core areas that you're going to be looking for them, is in the resolvers. So I got to ask you a question. What is wrong with GraphQL? Well, you know, in a database, you have grant, select, on, table, where, user, equal, whatever, right? They have a well-defined security model in the relational world. But in GraphQL, that really isn't defined. They give you different techniques, but it's not out of the box. So the other problem is that the queries are all embedded in the JavaScript client that's making the call to the GraphQL server. So think about this. Would anyone think there was a problem if I put a SQL database, I opened the port, and I put it on an EC2 instance, and I opened up to the world, 0.0.0.0.0. Anyone have any problems with that?
Yes.
Yes.
Exactly.
Client side.
Yeah, you don't want to expose your database to the internet. Now, the thing is, what I showed you before, where you said query equals any arbitrary query that you want to give it, well, that's essentially the same thing, right? I mean, this GraphQL is essentially kind of like a very simple database. You can think of it. you give it the query language, you give it the query, and it returns data. So no need for SQL injection, just submit your queries directly to the GraphQL endpoint. So you don't need to figure out, you know, single quote space or equal or no single quote space.
Little Bobby tables has evolved to the cloud.
Exactly. It's not even little Bobby tables. It's just little Bobby GraphQL. And all he does is whatever you want, he gives it to you. So what can go wrong? Well, that's where we now talk about the different vulnerabilities where things can go wrong. And these are the things that you have to be aware of when you're assessing the risk of GraphQL in your environment. So does anyone know what this is? Because it was kind of mentioned before, but does anyone know what you'd have to do to figure out what tables you could attack if you found a SQL injection? Is anyone familiar? So there's a schema, system tables schema, and there's like DBA underscore all underscore tables. There's the system tables. There's all these different tables. But GraphQL, you don't have to really
Just query.
Yeah, just give them the query, and this returns everything to you. All the mutations, all the types, all the directives, all the schema, all the everything. If you have introspection turned on. And some companies do on accident leave that on and deploy it out to the public, and then now the attackers got everything, right? Well, not everything in terms of your data. They have all the intel on your schemas, their relationships, but they can now craft more complicated queries and see if you have all the necessary protections in place to protect your data from leakage.
Oh, input validation and it's done everywhere all the time.
That is correct. Yes, input validation is very important. Oops, what happened? Okay. Okay. So what I want to talk to you now is about how, when you make a query, the query string or format is translated into database calls. So the items in red here are basically list types in the customer type object. So list types means that for every customer, a customer could have many invoices. And for every customer, there could be many transactions that they've made. And for every customer, there could be many tickets that they purchased, many events that they've attended, many likes that they've made, many messages that they've sent. So when I craft a query to get the customer, the ID, the name, the invoices, transactions, tickets, events, likes, messages, what that does in certain cases is that every one of these list types spawns a query to the underlying objects that are in the list. So if I have a list of invoices, then I have to select star from invoices and get all the invoices that are associated with that customer. If I have transactions for a user, then I have to select star from transactions where the user ID or the customer ID equals this particular customer ID. And I have to do this for all of the list types. Now, can anyone tell me what might occur if I have many customers that I need to query? Let's say I got 1 million customers that I got to query. Does anyone know what possibly is going to happen?
I don't know if you could crash the system, but
Exactly. You're going to overload the system, right? If
Crush the buffers.
So what I want you to do is a little bit of math with me right here, all right? So if we run this query and we're getting user objects and we say get the first 5,000. But inside that users object, there is a list of posts. Every user has posts. And so what I want is for every user of those 5,000 users, I want to get all their last 100 posts. And of those last 100 posts, I want you to return the ID, title, and body for each of them. Now, does anyone know how many nodes or objects would be returned from this query if the user actually, there were 5,000 of them, and if each user had at least 100 posts, how many different objects would be returned?
$15 million.
Almost. So it's 5,000 times 100 nodes, which is 505,000 nodes. So that's pretty bad, right? But what happens if I structure a query like this, where I've got, 1,000 posts here, I've got 1,000 authors here, 1,000 times 1,000 is 1,000,000. Then I recursively make the query go back to post, which there's 1,000 of. So now I have 1,000,000 times 1,000, which is 1,000,000,000. Then I got 1,000 authors, so I got 1,000,000,000 times 1,000, which becomes 1,000,000,000,000. And then I've got, what's after trillion? 1,000 posts here, 1,000,000,000,000 times 1,000. Then I got another thing.
You're getting into Scrooge McDuck territory.
Yes, exactly. So you understand how basically structuring these queries can lead to denial of service. Now, one of the solutions they say is to use something called the depth limiters, right? Okay, where, in the article they were saying, oh, just make this 3, right, depth. But what did I tell you about these enterprise schemas? They have hundreds, if not sometimes thousands of types. They're all related in all kind of crazy ways. And so when you do your query to just get some data, how many levels deep do you think these queries are going to get if you've got, a 300 or 1,000 schema object schema? Do you think it's realistic to limit your depth to 3?
No, you won't get a valid answer for
That's right.
the most common query.
And look at this, right? If we don't limit our depths to 3, but we limit it to 1, 2, 3, 4, 5, 6, 7. Let's say we just pick 7, right? We've got a query that's going to return 1,000,000,000,000 times 1,000 nodes, right? We're already blown past our limit. Now, they also have something called a rate limiting plugin, right? Where basically you can try to rate limit the number of queries you can give to GraphQL in a certain time frame. But the problem is that with batching, you can basically get around it. So even if you have a limit, let's say 10 every 60 seconds, well, I just need 1, but I'll put 100,000 different requests inside my 1 query to the server.
But isn't it also per session? So if a adversary spawns multiple sessions and reaches the limit, hits the query limit on multiple sessions.
Well, okay, so that's true, but here, if I set the limit to 10 every 60 seconds, I won't surpass the rate limit because I'm doing 1 every 60 seconds. But the thing is that 1, because of batching, which is supported in GraphQL, I can nest a bunch of mutations or queries inside of a single
Querying all the way down the canonical table, the branch.
Exactly, right? And so what this is doing is figuring out how you're given a 6-digit token to input for a 2-factor auth. right? This is figuring out what the value is in one go. So what do you do? Because the rate limits can't help you. You know, there's another thing where they rate limit, you know, trying to address this, they rate limit based on compute cycles. Now, can anyone tell me what would be a problem with this where you go, okay, I'm going to rate limit based upon complexity of 3. I mean, what do people think? Does anyone know what 3 means in complexity? I mean, if I've got this 300 type schema or this 1,000 type schema, and I build queries that are 20 layers deep or 10 layers deep at minimum, what does a complexity of 3 mean, right? Can I really put this in there, or am I going to start blocking my own users, right? I don't even know, right? What does a complexity of 3 mean when I've got different schemas, different types of relationships, different ways of optimizing the retrieval of the data? I've got to do a lot of testing, right? So the other thing is when you're looking at these resolver and the JavaScript code, does anyone know JavaScript? So in
Enough
Java,
to attack it.
I'm sorry?
Enough to attack it.
Okay, that's good. Okay, then what, do you know what these reverse ticks are meant for?
Escape.
Almost. So when we have this variable here, we're basically interpolating the variable into the surrounding string that's delimited by these reverse tick marks. So these reverse tick marks let us interpolate variables using the syntax of $ curly brace into the string. And what is the common thing you see in all the injection related vulnerability? What are they doing? It starts with C. But you can say C-O-N. But it's, yes, concatenation. So this is concatenation, right? Because we're interpolating, we're concatenating this variable into this string. And so that is the genesis of many of the vulnerabilities that are injection related. So you've got to keep track of that. At the same time, you've got to keep track of these new things, right? So for example, here we have a query where the name of the query is users, and it takes 2 parameters, but notice the parameter types. They're JSON. JSON has a parameter type? It sounds like a nightmare waiting to happen. Now, when we do a search and we want to return everything, the way you do it is you basically use this open curly brace $GTE : empty string, close curly brace. And that is basically equivalent to this single quote or 1 = 1 dash dash. Basically, you return everything, right? Normally, it's trying to find where the value is, you know, like equal to some value. But here you're saying greater than empty string, and that returns everything. And here we also have options here, which is JSON as well. And what that means is you can get pretty crafty with your payloads. So here, for example, when you do your search, you can say email equals this payload I was showing you before, which is like, you know, or 1 = 1. That returns every user. But then here in the options, you can specify fields : this. And now what we've done is we've overridden this field where it was limiting what fields are being returned. Now we're saying return all the fields. So, and this is because the type was JSON. So how do you solve that? Well, basically, you get more specific with the values that can be received, and you break them up. Instead of saying JSON, you segment out each individual attribute that you're going to be able to specify, and you allow the user to either specify it or not. And same thing goes with the options. You want to limit what options the user can specify to a predefined set, and then only allow those to be input in. And see this here, we got a number here, number. So now it's not JSON, which basically allows you to then override other fields in the structure or override other attributes in the structure. If you specify the actual type, then it's limited, right? They can't rewrite the query, so to speak. They can only add a number. Now, here, the way you query stuff is inherently predisposed to IDOR. So if you look, when you structure a query, the way that you specify what values to return is you specify an ID attribute or just an attribute of the object that it's associated with and the value associated with the attribute that you want to limit the query to. So here, you're getting the record with the ID having the value 1337, and then you're getting its edges attribute, and that edges attribute has inside of it a node. Inside of that, it has these attributes, and you can get these values back in the query. So the fix is basically to, instead of letting the user specify the ID, you make sure that the ID is associated with something that you've looked up yourself. So for example, if the user is logged in and if they have an ID, well then you pull that logged in user's ID from the context and you use that to do all your queries to ensure that the only data that can be returned is associated with the logged in user. The other thing that happens periodically and typically with the GraphQL is you have error messages. You have error messages in different logic, different resolvers, different levels. You know, when you write these huge queries, you're triggering a whole bunch of resolvers. And so when you get an error back, you can get more information about the resolver or the attribute you're trying to pull back. And typically you don't want to do that. You want to keep it as generic as possible. And cross-site request forgery is still an issue. So can anyone tell me what this mutation is doing? You know, all the cross-site request forgery vulnerability examples showed this, but what essentially have we done? We create this link, we obfuscate it, put it on a forum, fool someone into clicking on it, and if they have an active session, then what happens?
It will execute and I guess send money or send $1,000 to the
Right.
account.
Exactly. So I talked about this already before. These schemas, you have hundreds, if not sometimes thousands of types that have very, chained relationships across all these types. And when you expose the root element, you expose all the root element in all of the types that are nested within. So you got to be careful. And traversing all the paths is not easy if you have thousands of types. Trying to figure out what path you took, this time, that time, to see everything. There's also tools out there that basically will convert your Java or whatever classes into your schema by just looking at the class name, the attribute, the types. Can anyone tell me what would be a problem if I auto converted this object? What would be queryable?
The hash passwords and the
Yes.
usernames.
Exactly. So if I blindly auto converted my whole schema, certain fields are sensitive. SSN, CCN, password, is admin, you know, all this stuff. And that's right. I'd be removing it. I mean, not removing, I'd be exposing it. So the thing is, when you do the auto schema generation, make sure you remove those sensitive fields from the outputted models, outputted GraphQL types. All right, so let's get to recommendations for how do we address some of this stuff, right? So typically, you know, we're looking at here authorization and authentication. So there's web-based methods, there's putting security in your resolvers, and then there's schema directives. Now, here is a very simple way of enforcing authentication to your GraphQL server. Now, I wouldn't recommend doing it, but we're using something in Express called a middleware, which is basically similar to the ISAPI filters, you know, the NSAPI filters that used to run on the IIS and the Netscape web servers, probably dating myself. And then it's similar to the WebLogic filters, servlet filters that, you know, were J2EE. But you have something similar with Node.js called middleware. And here it's looking at every request. And basically they have this JWT library that basically allows you to authenticate every request by including the JWT in the request. And here, if you look at these two endpoints, there are two endpoints that the GraphQL is, or actually the server, Express server, is exposing. One is /comments and one is /GraphQL. Based on this configuration, can anyone tell me which of the two, /comments or /GraphQL, which one is public and which ones requires authentication?
/comments is public and /GraphQL goes to the middleware.
You got it. Yes. So this auth middleware here is what we configured and what's going to be intercepting every request to GraphQL to basically authenticate the JWT token that's being passed in there. There's nothing here. So basically it's open to the public. All right. So remember we were talking about the resolver logic. Can anyone remind me what they remembered about the resolver? What is its function in relation to the query and the database or the backend, you know, data store? What does the resolver do?
Converts the GraphQL query into a relational query.
Exactly, exactly. So this would be one of the logical places to put our security logic, because we can actually, we know what they're doing. You know, we can kind of check, we can make another query instead of going to database to our, you know, auth tables, and we can check if the user has certain roles, and that's what this is doing. So basically when the resolver gets a request, it's checking if the user ID, I mean the user from the user ID, what they logged in, has the manager role. And if it does, then it executes the logic to actually get the actual data and return it. But if it doesn't, then it's going to throw an error. The problem is that if you sprinkle this security logic all throughout your resolvers, it becomes very difficult to manage, because you've got to go through the resolver code. You know, it's just kind of spread all over the place. You don't know how consistent it is. It's not easy. So what they came up with was something called schema directives. So you define the directive, and it's like an annotation, basically, that you put on your mutations, on your types, on your attributes. And when those types, mutations, or attributes are referenced, then the directive logic is invoked, and it can validate, inputs. It can validate if the person making the call to query this field has a particular role, or are they authenticated. And the nice thing about this is to actually see your coverage. You go to one file, which is your schema file, and you look at all the attributes and see where you have schema directives associated with them, where you don't. You can look at all your mutations that are in the schema file, and you can see which ones have directives and which ones don't. So it's a nice organized way, and it's configurable, and it's not hard, it's not embedded in the code. And if you genericize your security logic, it's very easy to add and change this logic by adding it as an annotation on your schema object.
So Ed,
Yes.
question. So schema directives would be like similar to parameterized queries in table-based SQL.
It's a little different from parameter-based queries because, for example, how this has role or the is authenticated really is not really messing with the cost basis or the number of authors attribute. It's actually seeing if, since the user has specified cost basis or number of authors, a number of offers in their query, it's going to run this logic and make sure that, for example, if cost basis is an attribute that's in a query that's being submitted to the GraphQL server, what it's going to do is it's going to make sure that the currently logged in user has the role manager. So you could still have a SQL injection, but what it's doing is just it's making sure that whoever tries to get
You
this,
so it's an access control. You can access that next parameter, that next entity,
Like,
object.
you can access this cost basis, for example,
Right.
if you have the role manager.
Thank you.
That's right. You're welcome. Oh, okay. That is the end of the presentation. Any questions? What time is it? Let's see. Am I on time? Oh,
7:30.
wow. Perfect. 1 hour on the dot, almost.
Right on time.
All right. Thank you. Thank you. Okay. All right. Any questions? Going once?
Many,
Yes.
but
Yes,
you don't have enough time. You don't have enough time here to answer my question.
I can answer. It's all right. I'm happy to answer questions.
I'll write them up and email you.
Okay. All right. All right. Anytime. Anytime. Okay. Does Frank want to close things out? I don't know. How do we close things out?
Absolutely. Just give me a second here. I was going to jump back to my session.
Hey, thanks for digging in deep for the exponentiation of query depth.
Oh, you're welcome. You're welcome.
Querying a branch.
All right. Well, as the resident security expert on our team, Joe is definitely the person that I
sorry.
might need to. Yeah.
Abe and I have already met before.
Oh, okay, cool. Oh, yeah, maybe was it with Gene and
So as I was saying, definitely as a resident expert, I mean, there's no question that if you impress Joe, I think you impress the audience. Myself, I mean, You know, it's like you're definitely delving into areas I haven't spent a lot of time in a long time in a while, but fantastic presentation again. Thank you, and certainly in future events, you know, I invite you to attend our organization. I hope you're able to. And in fact, one of the first invitations that I'll extend to you, Abraham, and I extend to all our members that are attending here, is that ISC2 is will be part of the Interface Seattle. This is the one of the first events stated for December 9th at the convention center. So take a few minutes to sign up as an associate member, as an attendee, not even as a member. You get access to our link there, so you're welcome to use that if you're interested in joining us in December. Prior to that, as I mentioned, and I was kind of teasing, next month we are tentatively trying to set up an in-person meeting. In the slide that I have following this one had all the details. For now, it's hidden. So what I will do is I will recommend check back on our site in the next couple of weeks so that we can make sure that we can nail down the September session. Currently, it will be, if it is an in-person session, it will be a panel and it will be a presentation by myself and the leadership talking about the local chapter and talking about ISC2 as a whole and how it fits into the community. I really wanted to give an opportunity for everybody that joined the board and is supporting us to have an opportunity to be able to discuss what the benefits of the organization is, not because we're trying to sell it to you, but as in what is it that as individuals that are interested in security and cyberspace, compliance, what we can do to better the community. I've been on a mission for a long time, actually, to try to help in that space, and I'd like to continue that. And I invite everybody on the attendee, the 21, 22 people that have attended tonight and who review this this video once it's posted, to think about that is that as we become experts and we mature into this program, there's a lot of need. And the type of need, we're not talking about as much as humanitarian when you think about need, but in fact, cybersecurity has equal level of concerns. Interestingly enough, if you think about the humanitarian companies and organizations out there, if they don't home up, if they don't take care of their cybersecurity space, they're compromised. And that is our job to fix. You know, it was interesting. I was listening to a show earlier today about how cyber criminals were making a claim over the past year that they would not attack hospitals and medical centers because COVID was going on. So you can't, you know, that's not unethical. The problem is that, you know, the criminal organizations only say that to the public. Unfortunately, the people that they're attacking, you know, once you're a victim of an attack of somebody attacking you, you are a victim. It doesn't really matter. The attackers that are doing that have no sympathy whatsoever. It's a lot of times they're on top of that using botnets. So with that said, that's my soapbox, and I will be a soapbox that I'll be standing on for a long time. I hope everybody is interested in the conversation that we're going to have next month. And I really do look forward to hosting that as in person. It will, if everything lines up, we'll be posting some information, as I said, in probably the next week or so. It will be downtown Seattle, and it's 1 month from today. So anticipate that it will be September 2nd, I think is the Thursday. Everything going off without any crazy things going on with Delta variant of COVID, preventing us from being able to meet in person. I personally, and I invite everybody that has been vaccinated, I invite everybody that feels comfortable being in a room with others to participate. And I look forward to seeing you. This will be one of the first in over a year and a half, a year and something. To my board, thank you very much for supporting the chapter. Abraham, again, thank you very much for your participation. And if there are any last minute questions, please post them into the chat. Otherwise, I will go ahead and call this meeting to a close.